us continue to look at different kinds of distributions. So, Kriegland is a department store that sells various brands of plasma TVs. One of the manager's biggest problems is to decide an appropriate inventory policy for stocking TVs. He wants to have enough in stock that customers are going to receive their requests right away, but he doesn't want to tie up a bunch of money in inventory that's just going to sit on the floor. Most of the difficulty really results from the unpredictability of consumer demand. If the demand were known and constant, it would be easy for the manager to figure out what the appropriate inventory policy would be. But the demand varies week to week in a random manner. So we've been hired to determine the best probability distribution and to answer a couple questions. So we're going to create a histograph of the demand and identify a probability distribution. We'll calculate the variance and the mean. And then we're going to figure out what's the probability of selling no more than 15 TVs in a week, of selling at least 10 in a week, and then we'll worry about the last part here, but we're going to create a graph. So let's go look at our historical data. So our mean and variance we are going to find. And we're finding the variance here, not the standard deviation. So if we go equal average, and we're going to look at TV sold, go through 105 weeks, and so our mean is 1138. Now, we're going to find, we could find, let's throw that in there real quick, standard deviation. So if we come here, just going to lock in this matrix because I'll just change the functions, but we use the data that's in there. So if I go in there, what is standard deviation? Well, standard deviation is the square of the matrix. So stdev.s. We wanted to look at the variation, so let's take a look at that. So var.s, the variation, and that's going to give us a 12.34. Now, the mean and the variation are about the same. That actually tells us something. That tells us that we should probably be using a Poisson's distribution because the mean and the variance in a Poisson's will be about the same. But also, let's just confirm that. So we're going to insert our histogram. And X to copy it. I'm going to come up here, Control V to paste it. That right now that doesn't look much like a bell curve, but let's format the axes. Let's get some more bins in there. Let's see what will be a good number. Maybe 10? Is 10 a good number? Let's see. It's actually, because we're still getting some little, let's maybe 20? Look at that. Okay, yeah, 20 is better. It's not really a normal distribution, so even if we ignore these, it's not bell-shaped because it's definitely justified. It's right skewed. So actually, I can't really, I guess we can't say that because that is the mode. So it is kind of right skewed here. And it's got a longer tail here on the right. And so we go back and look at that variation in the mean. That's what I'm saying. It's like, that's a good example of what we should be doing for a Poisson's distribution. And so that's what we're going to use. We'll use a Poisson's distribution. So let's go to our third page with the model. And look at that, we already knew it was going to be a Poisson's distribution. So we want the mean weekly demand. So let's go over here and grab it from our data, and that's the mean. So our mean weekly demand is 11.8. Okay, so now we wanted to answer a couple different questions. We wanted to know what's the probability that we're going to sell less than or equal to 15 TVs. So we're going to go in, Poisson's distribution. Poisson's all we have is the one distribution. So less than or equal to, so 15 is our x. We are going to look at our mean. Notice that we don't worry about standard deviation or anything within a Poisson's distribution because that variance is so high, but we do want it to be cumulative, so we want the chance of 15, 14 all the way down. And so there's an 85.7% chance that we're going to sell 15 TVs or less. And so once again, that's calculating less than. So now we want to do greater than. So more than 10, so what are we going to do? We're going to do 100% possibility minus, we are going to do the possibility that we're going to sell at least 10. So we're going to do less than 9. Because if we take away the probability that we're going to sell 9 or less, that means that we're going to sell at least 10 of them. So we're going to do 9. We're going to times it by our mean. We want it to be cumulative, so the chance that we will sell at least 10 is going to be 74.2%. Okay, and so now what we want to do is go down and do each individual probability so we can make a graph. So we're going to equal, there's our Poisson's distribution. We were going to go with our value. We're going to multiply that by our mean. We're going to lock that in because we're going to drag that down. We want it to be cumulative, so that's going to be 1 for true. And so there's a 0% chance that we're going to sell 0 TVs. Double click, drag this down all the way to 30. And so I did something incorrect here. And so what did I do incorrect? Is I gave cumulative. I want to know individual probabilities, so I don't want cumulative. So I want to make that false because I want the percentage chance that each one of these is going to happen. What's the difference? So before I had, this would have been the percentage chance of 5 or less. Now this is a percentage chance of 5. Just 5 on its own. And the reason that we did that is so I can calculate out my Poisson's graph. So what we're going to do is we're going to come here, I'm going to highlight all of our probabilities, we're going to insert, and instead of using a histograph, we are going to use a bar chart, and actually we'll use a column chart. But we'll select our columns here, and there is our Poisson distribution, the percentage chance for each of these units. And once again, though, let's be complete. And this is going to be number of units sold. This is going to be our frequency. And this is going to be our Poisson's distribution. With lambda equal to 11.83. Okay, and so there's our distribution, and that's all we have for this problem. So this, we won't see Poisson's, oh, misspelled that. We're not going to see Poisson's all that often. You are far more likely going to see the normal and the binomial, but it's always good to know what's going on with this, especially when we're dealing with completely random demand.